All right, one more problem, and then I'll let you guys go. Let's say that you invest $3,000 in a CD, and I don't mean a musical CD, I mean a certificate deposit. It's a type of bank account. And after a year, it's worth $3,105. You've invested that money, okay? Well, what's the percent growth for each year? Well, this is the current term, okay? And this is the previous term. So we're going to take that, we're going to take 3,150 and divide it by 3,000. Okay, we've taken the current term, we've divided by the one the year before. Let's just stick that in our calculator and see what we get out. We'll go quit, clear that. And we'll say 3,150 divided by 3,000. And hit enter. Oh, look at that, 1.05. Now, the question asks, what is the percent growth? In other words, what percent did that CD give me? Well, what's the difference between 1.05 and 1? So if I say 1.05 minus 1, that'll tells me that I get 0.05, and 0.05 is a 5% increase. So I'm getting 5%, which if any of you guys have savings account or anything, 5% is pretty darn good. Let's write an equation now. So I know my B, right? Let's assume, I can assume any of these is my A. Since I started with 3,000, I'll put that as my start amount. So I'll say, I'm going to call it CD of X equals my start amount, because it's Y equals A times B to the X. My start amount, I'm going to use 3,000 times 1.05 to the X. So now I got my equation. Now I want to know how much money will I have after 5 years. Oh, that's something I need to be clear about, don't I? So X represents years, and CD of X, or my Y, represents money. Okay. So how much money will I have after 5 years? So I'm gonna take in, I'm gonna put in CD of 5 equals 3,000 times 1.05 to the 5th. Okay. Now once again, I can just plug that into my calculator here, and I can say 3,000 times 1.05 to the 5, because that's after 5 years. And you'll see that I earned $3,828.84. So CD of 5 equals $3,828. And what was that? $28.84. Okay. Now when will I double my money? Well, let's look at it. Once again, probably the easiest way is to enter it in the So I've entered it in my calculator here. 3,000 times 1.05 to the X. And now I'm going to go to my table. I'm going to check and see when that equals. So here we go, 3,000. And I'm trying to find out when my money's going to double. So I'm going to just scroll down here. Oh, starting to get up there. 5,100, 5,300, 5,000. There we go, 5,000. So in between 14 and 15 years, right? Pretty close to 14. Then we're going to be we're going to have doubled our money in 14 years. So I know that, and the way that I can show that work is I can say, double my money, 3,000 times 2 equals 6,000. Okay, and by looking on my list, I can see that somewhere around 14, a little over 14 years, I'm going to end up with $6,000, which is twice that amount. Anyway, I guess my big takeaways from this are exponential growth functions grow by a constant multiplier. And so the big takeaways from the day are exponential growth functions grow by a constant multiplier. And what that allows us to do is take any term and divide it by the previous term, will give that multiplier. Also, the start amount occurs in the list when x equals 0. Also, you can assume, kind of a subnote to that, is if you have a couple data points, you can assume that the first data point is the start amount for now. And as we saw yesterday, and the last thing that I want you to know is the percent change is the difference in B. Percent change is the difference between B and 1. Okay, and that oftentimes you'll have problems where you're given percentages and we'll need to know how to find B, and sometimes we'll be given B and we'll want to know how to find that percentage. Anyway, I hope this is helpful. Finish filling out the sheet, and tomorrow in class we'll make sure everybody's on the same page and do our homework. Thanks a lot.